morning. I am Ananthi, Assistant Professor, Biomedical Engineering. Now I am going to take a class on Colpitts Oscillator. So now let's move on to the topic. Now let's see the background about the Colpitts Oscillator. Normally, an oscillator is a circuit that outputs a repetitive electronic signal. That means it may be a sine wave. Colpitts Oscillator is known for using a capacitor voltage divider as its feedback source. So it has some advantages. It includes frequency stability and it is simple and robust design. So for oscillation, to occur the Barkhausen criteria must be met. Barkhausen criteria means we have two loop gain condition. First one is phase shift must be equal to 0 and the magnitude is equal to unity. That is, realistically the magnitude will be greater than 1. So we have two conditions. The magnitude of loop gain should be greater than 1 and it should be equal to 1. Our goals are design a Colpitts oscillator using it for lighting the fluorescent lamp, and it should build and test the design, and it should obtain the frequency of oscillation. Then output is a non-distorted sine wave from self-oscillation. So it is on practical Colpitts oscillator circuit. In this we are using 3 circuits for Colpitts oscillator. It is the first one, and its construction is, let us first take a look at the circuit diagram of the Colpitts oscillator. In this we have using 3 resistors, R1 and R2 and RE. RE provide necessary bias condition for the circuit, and the capacitor CE provides a AC ground, thereby providing any signal degeneration. This also provides temperature stabilization. The capacitors CC and CB, base capacitors, coupling capacitors, are employed to block DC, and it provides an AC path. The radio frequency choke offers very high impedance to high frequency currents. That means it shorts for DC and opens for AC. Hence it provides DC load for collector and keeps AC current out of DC supply source. And the tank circuit is the frequency determined determining network is a parallel resonance circuit which consists of variable capacitors, that is C1, C2, along with an inductor L. The junction of C1 and C2 are earthed. The capacitor C1 has its one end connected to vias CC and the other two emitter via CE. The voltage developed across C1 provides the regenerative feedback required for the sustained oscillations. So next, this is the second circuit diagram. Note down this, and another one third tier circuit diagram. This is the third tier circuit diagram. The operation is, when a collector supply is given, a transient current is produced in the oscillator or a tank circuit. The oscillatory current in the tank circuit produces AC voltage across C1, which are applied to the base emitter junction and appear in the amplified form in the collector circuit and supply losses to the tank circuit. If terminal 1 is at positive potential with respect to terminal 3 at any instant, the terminal 2 will be at the negative potential with respect to 3 at that instant, because terminal 3 is grounded. Therefore, points 1 and 2 are out of phase by 180 degree. as the CE configured transistor provides 180-degree phase shift and it makes 360-degree phase shift between the input and output voltage. Hence, feedback is properly phased to produce continuous undamped oscillations. When the loop gain is the product of gain and the feedback factor beta of the amplifier is greater than 1. Oscillations are sustained in the circuit. This is the operation. So next slide. This is the output signal. We have to note the number of squares. We found that the frequency is 9 kHz and the output voltage is 200 volt. This is the another one waveform of the output. So, thank you.